great to see everybody in my A-Day and B-Day classes. Well, actually, I can't see you, but you can see me. Now, we're going to jump right into it. We're on page 234 of the workbook. Question. What is this symbol here that you see on the screen? You learned it in 5th grade, and you learned it again in 7th grade. At this point, I hope you said pi. Pi is going to be a really important number for us. And I'm going to explain why we actually give it its own symbol. So this is the Greek letter pi. We spell it just like this, P-I. And it's a Greek letter that we use when we want to calculate area and when we want to calculate circumference of circles. And that's what we're going to talk about today. But first I wanted to explain why it's so important that we gave it its own symbol. The reason why is because it's an irrational number. And so an irrational number is one that can't be expressed as a fraction. It's not like 1/2, 1/2, or 3/10, like 3/10. This number repeats forever and ever and ever. So for those of you who remember this number from middle school, most people said pi equals 3.14, right? That's what we told you in middle school. Well, actually, pi approximately equals 3.14. Really, pi goes on forever and ever, and it's closer to this number, 3.1415926535, and it keeps going on forever and ever and ever. Thousands and thousands of numbers come after this 3.14. But we want to be precise, right? So we learned about what happens when we round off numbers. We lose precision. Because of the number, if it's rounded, it may not be the exact answer we're looking for. So sometimes we don't round off at 3.14. It's important that we're able to use all these important numbers in pi. And so that's why we use the button on our calculator that says pi. So I just want to go over that. We're going to see exactly what it means as we go into actually how we calculate radius, or actually how we calculate circumference. So turn over to page 234. So on page 234, we start to learn about what circumference is and how we use that to calculate arc length. For this video, we're just going to be talking about circumference. So this is going to be a little bit of a review. If you remember this from middle school, this is really good. If not, pay close attention to this video, and as always, feel free to stop and start when you need to. So our first vocabulary word at the top of page 234 is circumference. For circumference, I just want you to write the total distance around the outside of the circle. The total distance around the outside of the circle. So the total distance around the outside of a circle, that's our circumference, and that's what we're going to learn how to calculate today. So scroll down with me to where it says theorem 6.19. So this, once again, should be a little bit of review. Before I jump into the actual formula, I want to take some time to review our vocabulary words. Now, radius and diameter. We said that radius is just the length from the center of your circle to any point on the outside edge. That's a radius. It's not perfectly in the center, but you get my point. Any point from the center of your circle to the outside edge. Now, if I want to find the diameter, it's going to be the distance from a straight line distance from one end of the circle to the other, but it has to pass through the center. So looking at this, you can tell the relationship between the radius and the diameter. Whatever the radius is, the diameter is going to be double. Whatever my radius is, I'm going to multiply it times 2 to get the diameter. So, that being said, let's take a look at our formula. It says the circumference C of a circle is C equals pi times D. So it can be pi times D, or C equals 2 times pi r. It's 2 pi r because 2 times r is going to be d. 2 times r will give you the diameter. 2 times the radius will give you the diameter. And then we multiply that diameter times pi. So 2 pi r, that's where we get that from. So d is the diameter, and r is the radius of the circle. So down here where it says c equals, I want you to put pi d, and that equals 2 pi r. Simple enough. Once again, this is review. Let's jump into actually how we're going to use this to solve a problem. So it says the circumference of a circle with radius 11 meters. So our formula is d equals 2 pi r. This time it says r is 11 meters. So I already know that r is the radius. So c is going to equal 2 times pi times 11 this time. Times 11. And now what we're going to do is just simplify one step at a time. So we know 2 times 11 is 22. So 22 pi meters. Here's a quick key. Sometimes we want to be precise. If we ever want to be exact, we're just going to leave our answer as 22 pi. Because if I say 22 times 3.14, I'm going to round off. And whenever I round a number, I lose some of that accuracy. Sometimes the number's off a little bit. But if it's a situation where I actually want to know what meters are or what the yards are, if I say how far is it from my end of the block to your end of the block, you're not going to tell me 2 pi blocks away. I actually need to know. Even if it's a little estimated, even if it's a little approximated, I need to know a decimal. I need to know some type of approximate number. And that's why we have our approximately equal sign here. So 22 pi, and your calculator is just going to do 22 times, I want you to actually use the pi button. And if you don't have a calculator on you that has pi, you can just use 22 times 3.14. That's going to give you your estimate. So 22 times 3.14 is going to give me about 69.1 meters, approximately. So that's an easier example. You've worked through those, like I said, in middle school. Let's talk about this example. This time they give me the circumference. I want to find the radius. The formula stays the same. C equals 2 pi r. And now, I know the circumference. I know what C equals. C equals 18. So instead of saying C equals 2 pi r, I'm going to say 18 equals 2 pi r. Now, all we're going to do is solve this equation for r. We're solving it for r. R is that variable we want to get by itself. Well, right now I see r is being multiplied by 2 pi. It's the same thing as if this was 3r. We would divide both sides by 3. This time it's 2 pi r. We're going to divide both sides by 2 pi. So, divide by 2 pi on this side. Divide by 2 pi on this side. Now, pay close attention. Now I have 18 over 2 pi. I'm going to need to simplify this. Well, I know 18 divided by 2 is what? Well, I can simplify that. Now I have 9 all over. So I have to leave that pi on the bottom because it was in the bottom of our fraction before. So now I have 9 divided by pi. 9 divided by pi equals r. Once again, they give me that approximately equal sign for a reason. I actually want to know approximately how many yards this is. So in your calculators, I want you to do 9 divided by pi. Or if you don't have a pi button, I want you to do 9 divided by 3.14. That should give you something close to 2.87 or so. Around 2.87. About 2.87 yards equals r. Now here's a way you can check that. It says that r is my radius. The circumference has to be 18 yards. C always equals 2 pi r. So let's check that using the r that we know. Well, 2 times pi times this r that we got, 2.87. That gives me about 18, in my calculation, about 18.03 is just about 18 yards. Remember, we approximated, so it's not going to be exact, but that's a good answer. So, using that method, I want you to practice circumference. Once again, this is review from middle school, but I want you to take your time when you're solving these problems. Here's what I want you to get done. The checkpoint right below this, at the bottom of page 234, I want you to answer the checkpoint question. And also, flip over to page 236. I want you to finish questions 1 through 7 on page 236. Please, as always, let me know if you have any questions. I'll be in my room. Text, tweet, email, Ogbonna, anything, let me know. All right, thank you.